let's take a look at the first one at least and see how you're doing. Then I can give you some more time on the second one if you need it. So we'll move this one down out of our way for a second. So up here, what do we have to do first? Well, we see the parentheses, so we have to work in there first. But inside there, what has to happen first? The division. Now, 3.5 divided by 1 3/4. So, I'm going to write that out. This is just like order of operations with whole numbers, only the calculation is a little bit more complex. So, 3 times 2 is 6, plus 1 is 7/2. 1 3/4 becomes how many fourths? One times 4 plus 3, 7. There we go. So now the first number never changes, so that stays 7/2. We multiply and take the reciprocal of the second number, so that's 4 over 7. So the 7's cross cancel, giving us 1 and 1. 2 and 4 cross cancels, both are divisible by 2, giving me 2 and 1. So 1 times 2 is 2, 1 times 1 is 1, 2 over 1, or just 2 is the result there. So 3.5 divided by 1 3/4 is 2. So now we're looking at 7 1/3 subtract 2 as being the next operation we have to do. When we add or subtract, we need common denominators. But the 2 is just a whole number. It doesn't have a fraction. So to work with that, we can do it a couple of different ways. We can set it up just like this, and we can say, well, there isn't a fraction here, so there's nothing to subtract from the 1/3. Or you can say, hey, that's just like after a decimal point, you would point 0. You can say that's 0/3 here, and do 1 minus 0 is 1/3. Either way, we end up with 1/3, and 7 minus 2 is 5. So 7 1/3 minus 2 is 5 1/3. So now, what's our last step inside the parentheses? We're going to do the subtraction, right? So we have 5 1/3 minus 5/6. We do need a common denominator, which is going to be what? Thirds and sixths, it'll be 6, right? So 3 times 2 makes 6. 1 times 2 makes 2. 6 times 1 makes 6. 5 times 1 makes 5. Subtracting here, we're going to have to borrow because we can't do 2 minus 5. So we borrow. This is 4. Our denominator tells us what we have to add on here. So we add 6 to the 2. That's 8/6. So it's now 8 minus 5 is 3/6. 4 minus nothing is 4. Of course, you might recognize that 3/6 can be reduced to 1/2. So that is 4 1/2. Now we can take out the parentheses because we're down to a single number inside of them. We have to remember to do what up here? Talkative group today. What do we have to put in here? I heard somebody whisper it there. Multiplication. Good. It's multiplication. So now we have 2 operations left. Which one's going to happen first? Again, the multiplication. 2/3 times 4 1/2. So I'll make some more room here yet. So 2/3 times 4 1/2 is going to become 4 times 2 is 8 plus 1 is 9 halves. The 2's cross cancel to give me 1 and 1, both divide by 2. 3 and 9 can divide by 3 to give me 1 and 3. 1 times 3 is 3. 1 times 1 is 1. That is just 3. So I now have 3 1/2 plus 3, which is 6 1/2. There's no fraction here, so I can just combine the 3 with the other 3 and keep the 1/2 on the end of it. Any questions on that? Good. Okay. Down to the other one. So we have this fraction bar across here. And if you recall, that was a form of enclosing symbol. Does anybody need another minute to finish that one up? Ready to go? Okay. Need a minute? Okay, I'll give you another minute. I'll pause it here for a second. So we have to start out on top. 3 1/8 times 4 1/5. One of you guys lead me through it. What's going to go up here? Three times 8 is 24. Plus 1 is, there we go, 25/8, right? Changing the 3 1/8 into an improper fraction. So then the 4 1/5 is going to become 21/5. Good. Can we reduce anything before we multiply? $25 and 5, right? Both of those can be divided by 5, so we're going to get a 1 and a 5 here. So 5 times 21 is 105. 8 times 1 is 8. And now we do have to divide that out to, well, you know what? We're going to have to divide here eventually. So I'm going to leave that as an improper fraction right now. 105 over 8 is what I have on the top. Since I'm going to divide by whatever I get on bottom anyway, why bother changing that back into a mixed number when I need it as an improper fraction to divide? So now down on bottom here, I do have to subtract. 2 and 5/6 minus 1 and 3/8. What's my common denominator going to be? $24, good. So this is going to be what up here? Six times 4 makes 24. 5 times 4 is 20. Perfect. What goes here? Eight times 3 to make 24. 3 times 3 is 9. Good. So now we do have to subtract. 20 24ths minus 9 24ths is 11. 24ths. 2 minus 1 is 1. So we're going up here. We have 1 and 11 24ths. Looking at it like that, it looks a little awkward, but all that really is 105/8 divided by 1 and 11 24ths. Now it still looks a little awkward because it's already an improper fraction, but we're going to have to change the 1 and 11 24ths to an improper fraction too. That's going to become 1 times 24 is 24, plus 11 is 35 24ths. What do we do next? first fraction never changes, 105 over 8. We change it to multiplication by the reciprocal, 24 over 35. Now what? Well, yeah, we can cancel. We could multiply straight across, but we can cancel here if we want to. 8 and 24 can both be divided by 8. Give me 1 and 3. 105 and 35 can both be divided by, you probably see 5 right away. So let's do that. 35 divided by 5 is 5. 105, or not 5, 35 divided by 5 is 7. 105 divided by 5 is 21. Now, if I'm looking at that closely, the football players in the room might catch this. 7 and 21 can both be divided by 7. So let's divide by 7, we get 1. 21 divided by 7, we get 3. I knew where you were going. You were already dividing out the 7, right? So 3 times 3 is 9. 1 times 1 is 1. 9 over 1, or 9, is our answer for that. Did anybody get 9 for that one? Okay, good deal. How many of you have started using your calculators for the fractions? Okay. And usually at this point, that's what happens. I mean, I'll admit I don't keep plugging away with my fractions by hand either unless I have to. So what I want to do today is I want to look at some applications of fractions, since they are very, very prominent in wood construction. Just so you know, I do have your quizzes from last Friday. I was a little bit under the weather yesterday, so I didn't get them graded. So I will have those graded and back to you by this Friday, so you have them for class. There's a new quiz today that we'll be taking too, so I'll make sure I give you a little more time today instead of cutting you short like I did last week. So anyway, some of our applications of fractions that we want to look at. We might have a cabinet door. And this cabinet door is going to be 2-paneled. And if we look at this door, the rails are going to be 2 3/8 inches. So that's there, there, and there. Each of those is 2 3/8 inches. The panels that go in here are each 18 and 7/8 inches. But notice how I drew them. I drew them actually bigger than the black square. The reason for that is they set into the rails 1/4 inch on each side. So how big does this door end up being? Well, the first thing we have to figure out is what the actual distance is from here to here. Oops, where did I lose my 18? My computer's been doing some funny things today. That was 18 and 7/8, right? So let's look at this. This is our panel, and that full panel is 18 and 7/8 inches. We want to know how much of that is exposed here in the middle if 1/4 inch on each side is buried into the rails. Now there are a couple of different ways we could approach this. We could take the 18 and 7/8 and we could subtract 1/4 from it twice. But since we're going to subtract the 1/4 twice, and it's a relatively easy calculation to combine 1/4 and 1/4, it would be easier for us if we add the 2 1/4 inch dimensions. 1/4 plus 1/4. 1 plus 1 is 2. And remember, when we add, we keep the same name. So fourths stay fourths. 2/4, which reduces to 1/2. Now, as you get further into construction and working with wood more, at some point, you should get to where you look at 1/4 plus 1/4 and know that that is a half. So what we're losing on this panel is we're losing a total of 1/2 inch of height by taking 1/4 inch off the top and bottom. So from our 18 7/8, we are going to subtract 1/2 inch. 1/2, of course, can be changed into eighths. 2 times 4 makes 8, so 1 times 4 is 4. 4/8 is a 1/2 inch. So I'm just going to go ahead and subtract right here. 7 minus 4 is 3/8. And then the 18, there's no whole number to subtract, so that stays 18. So what we are filling here, from here to here, is actually 18 3/8 inch gap. This one down here should be the same. We have the same if we have the same size panel and the same sink into the rail. So now we just need to find an overall height. We have 2 3/8 here, here, and here. So let's combine that. I could take 2 3/8 plus 2 3/8 plus 2 3/8. I'm going to speed it up by multiplying by 3 instead of adding it 3 times. So that'll become 3/1. When I multiply, do I need a common denominator? No, I don't. But I do when I'm using mixed numbers, I do want to change it to improper fractions. So 2 3/8 is going to become how many eighths? Perfect. 2 times 8 is 16 plus 3, 19/18. Hey, you tried. It's okay. So now we've got the 19 times 3 is 57. 8 times 1 is 8. So 57/8. We're going to reduce. 8 goes into 57. 7 times, that would be 56, with 1 left over. So that is 7 1/8. So the 3 2 3/8 inch rails, this one here, here, and here, add up to be 7 1/8 inch. Now to that we have to add the 2 panels that we found are 18 3/8 inch of exposure each. So 18 3/8. I could multiply that by 2, but I think it's going to be easier just to add it to itself. So here's a case where I had 2 options. I could multiply or I could just add it to itself. And to me it looks simpler just to add it. 3/8 and 3/8 makes 6/8, which yes can reduce to 3/4. 8 plus 8 is 16, so 6 carry the 1. 1, 1, and 1 is 3. So 36 3/4. Now as I look at that, I'm going to go back to that 6/8 instead of 3/4. It's the same thing. I'm just going to go back to before I reduced it. Can anybody see why I would want to do that? Because my other measurement from the 3 rails is in eighths. And when I'm going to add them, I'm going to need a common denominator. So to the 36 6/8, I'm going to add 7 1/8. 6 plus 1 is 7/8. 6 plus 7 is 13, so 3 carry the 1. 1 and 3 is 4. So 43 7/8 is the overall height of that door. Make sense? So now I have a board here. This board, end to end, notice I didn't draw the end square. End to end at its longest point at either end has a length of 58 and 3/8 inches. I estimate that in order to square up the ends, I'm going to have to cut off 3/8 of an inch on each end. I want 4 equal pieces out of this. So once I've squared off the ends, I want to get 4 equal pieces out of this. Now, one thing you'll learn about working with wood is your saw takes out a chunk of wood that we have to account for. It's what we call a saw kerf. The kerf is the amount of wood that is removed by the saw itself. So each saw kerf is 1/8 of an inch. So I want to know how large each of these 4 pieces is going to be if I make them the maximum size. Now, one thing to clarify here, when I'm squaring up the ends, my saw kerf is going to be included in that 3/8 of an inch. So I don't have to take that 3/8 plus another 1/8. The saw kerf is on the outside of that. So we need to start out. Now you'll notice I wanted 4 equal pieces. How many interior cuts did I have to make? Only 3. So I only have 3 of those to account for. When we're working with numbers, you'll see me do some fairly large calculations in my head. And I've mentioned it a little bit that math calculations are about patterns. And when you start to see patterns, the calculations become easier. And here's a case where you see something. I have 1/8, 1/8, and 1/8. If I add those together, 1/8, 1/8, and 1/8. 1 plus 1 plus 1 is 3/8. Those 3 saw kerfs make 3/8 of an inch. I also have 3/8 of an inch being cut off of each end. So the total that I'm going to lose to my saw kerfs and squaring up my ends is 3/8 times 3. I could have done 3/8 plus 3/8 plus 1/8 plus 1/8 plus 1/8. That would work too. For some of you, that might actually be easier because you have 3 plus 3 is 6, plus 1 is 7, plus 1 is 8, plus 1 is 9. You're going to get 9/8. You get the same thing here. 3 times 3 is 9, 8 times 1 is 8. So 9/8 or 1 1/8 inch is what we're going to lose to our saw cuts and squaring up the end. So that means out of my 58 and 3/8, if I'm going to lose 1 1/8, I have to subtract to see how much good wood is going to be left over. So 58 and 3/8 minus my 1 1/8. They're already in common denominators. So 3 minus 1 is 2/8. That can be reduced to 1/4. 8 minus 1 is 7. And 5. So we have 57 and 1/4 inch of good material that'll be left after all our cuts. What do we have to do with that 57 and 1/4? We have to split it into 4 pieces. We have to divide it by 4. Very good. So to divide by a whole number, we make our whole number a fraction by putting it over 1. We're going to have to make this an improper fraction. Now this one, I imagine, I definitely wouldn't blame you for using the calculator on. 57 times 4 is 228, plus 1 is 229 over 4. Instead of dividing by 4, we're going to multiply by the reciprocal, which will be 1 over 4. 229 times 1 is 229. 4 times 4 is 16. Then we got to divide out. 229 divided by 16. 16 does not go into 2. Goes into 22 once. There's 6 left over. Bring down the 9. 16 goes into 69 4 times. That's 64 with 5 left over. So 14 and 5/16. Each piece will be 14 and 5/16 inches long. Any questions there? Okay. Let's look at a stairwell. We have from one floor to the next. I'm just going to give this in inches so we don't have to convert feet right now. 111 3/4 inches from one floor to the next. We need to put in a stairwell here. Pretend those look even. So on our stair, we have 2 dimensions we work with. We work with a rise, sometimes called a riser, and we work with a run, which is often called a tread. When you're working with a stair, you want that rise to be as close as possible to 7 inches. So we'll start out by estimating how many steps, how many rises we'll have by dividing by 7 inches. So we're going to take our overall height, 111 3/4 inches, and we're going to divide by 7. Now if you have your calculator, this one's not bad. Doing it by hand, it'll get kind of ugly. 111 times 4 is 444. Plus 3 is 447 over 4. Make that 7 over 1, so it's going to be times 1 over 7. 447 times 1 is 447. 4 times 7 is 28. So now we have to turn that back into a mixed number. So 28 goes into 44 once. That's 28. We subtract, we're going to get 16, bring down the 7. 28 goes into 167. Oh, let's see here. Will it go 6 times? Not quite, will it? It's going to go 5 times. 5 times 8 is 40, so 0, carry the 4. 5 times 2 is 10, plus 4 is 14. We got 27 left over. So that's 15 and 27/28. Now remember, what we were calculating was the number of rises. How many of these rises we can have. Can we have 15 and a fraction of rises? No, we can't. So what we're going to do is we're going to round this up to 16 rises. So what that means is our 7 inches is not going to be exactly what our rise is. We're going to want to adjust that just a little bit. So we're going to take our 111 3/4, or total height, and divide by 16 to get what the exact height of each rise would be. Well, this is going to be very similar to our dividing by 7. This is still going to be 447 over 4. We're going to change dividing by 16 over 1 to times 1 over 16. 447 times 1 is 447. 4 times 16 is 64. Now we divide it out. 16 does not go into 4. 16 goes into 44 twice. That's 32 with 12 left over. Bring down the 7. 16 goes into 127. Oops. What went wrong there? Oh, that should be 64, not 16. What am I thinking? Let me back off. Sorry about that. I was getting ahead of myself. What needs to go here? 64. I'm dividing by 64. So 64 does not go into 4. 64 does not go into 44. 447, it's going to go 6 times. 6 times 4 is 24, so 4, carry the 2. 6 times 6 is 36, plus 2 is 38. So now I have to subtract. 7 minus 4 is 3. 4 minus 8, I'm going to borrow. That'll be 3 and a 14. That's 63. So 63 64ths. So each riser is 6 and 63 64ths. To be honest, that means they're basically 7 inches. On a job site, cutting a 64th of an inch off is going to be basically hitting it with a sander. So anyway, what if we do have to account for it though? If we just tried to do them 7 inches, how far off would we be? Well, each of them would be off by a 64th, and there's 16 steps. So 1 64th times 16 is 16 64ths, which reduces to a 1/4 inch. So if you didn't account for that 64th of an inch, your bottom step or your top step 1 would be a 1/4 inch off. Any questions so far? I'm going to give you guys one to try here, maybe a little bit simpler. We're going to build a stud wall for a house here. The stud wall itself is 5.5 inches thick. On the exterior of the wall, we have sheeting that is 7/16 of an inch. And on the outside of the sheeting, we have 3/4 of an inch of insulation, of foam insulation. On the outside of that, we have siding that is 1 3/16 inches thick. Obviously, this is all not drawn to scale, by the way. And on the inside, we have 1/2 inch of sheetrock. Find for me the total thickness of that wall. So what all do we have to do here to find that thickness? Just adding them all up. 1 3/16 plus 3/4 plus 7/16 plus 5 1/2 plus 1/2. Now I mentioned earlier when we were doing that saw curve problem, there are patterns. There's little things you can see that make life easier on us. So I can combine these in any order. I just have to add these 5 dimensions up. So I look here, what's 5.5 plus 1/2? 6. Good. I can also combine my 1 3/16 and 1 7/16 because they have the common denominator. Or not just 7/16, not 1 7/16. 1 3/16 plus 7/16. 3 and 7 make 10/16. 1 and nothing makes 1. The 10/16 can be reduced to 5/8. So that is 1 5/8. And now I still have my 3/4. So I'll put 3/4 over here. Well, since the 6 is a whole number without any fractions, I can combine it to either of those real easy. I'll just combine it with the 1. So I have 1 and 6 makes 7 and 5/8, and we're going to add 3/4 to it. 3/4 can be changed into 6/8. So 5 and 6 make 11/8, which is 1 and 3/8. I will keep my 3/8, carry my 1. 1 and 7 makes 8. How many of you had 8 and 3/8 inches for that wall thickness? Good deal. Now I'm going to have you try this next one. We're going to be framing for a door. Be framing for a patio door, to be more specific. This patio door is big enough that we need 2 jack studs. And we need 2 on each side. Each jack stud, we're going to be doing this, is going to be a larger shear wall. It's going to be more than 2 stories tall. So we're going to be building it with LVLs. So each of those jack studs is 1 and 7/8 inches. So there, 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 and there. The door that we are putting in here is a 72-inch door. 72-inch door, though, is a 73.5 inch to the outside of the frame. And to install it, we need 3/8 of an inch of clearance on each side of the door to have room for shimming it and insulating it. So what I'm asking is, what's the total length that this header up here has to be to go over that door? In your notes, go ahead and try to figure that one out quick for me. Okay, so what we have here is just 7 dimensions that we have to add together. The 1 and 7/8 is in there 4 times. The 3/8 is in there twice. Then we have the 72 and 1/2. I'm going to change that to 72 and 4/8. So, adding up, I've got 7 plus 7 is 14, 21, 28. Plus 3 is 31. Plus 3 is 34. Plus 4 is 38. That's 38/8. 4 goes into 38. Well, 8 goes into 38 4 times. 8 times 4 is 32. So that'd be 6/8 left over. 6/8 is 3/4. We'll carry the 4. 4, 5, 6, 7, 8. Plus the 2 is 10. So 0, carry the 1. 1 and 7 makes 8. 80 and 3/4 inches. How many of you had that one? Okay, that one's a little bit tougher. So the next one I want to look at, we're going to create a window frame. We need to build a wooden frame to replace the frame for a double hung window. And so what our frame is going to look like, we'll see if my artistic abilities can handle this. There may be a very good reason why I am a math teacher, as we've mentioned before. I'm definitely not an art teacher. Okay. I guess it's not going to turn out too bad. To assemble our window, course, it'd be the same on bottom here. I just ran out of room. To assemble our window here, the overall dimension of the opening is 32 3/4 inches. So this has to be 32 3/4 inches from here to here. That's after we've figured in our 1/8 inch of clearance on each side. So we're probably looking at a 33-inch opening there. Each side of the window here is 2 3/4 inches to match the other windows. But to put this together, we're going to do a tongue and groove to hold this together here to give it some extra support. And that tongue is going to go in 5/8 of an inch to the side rails on each side. So what I need to know is how long does this piece have to be from here all the way to here so that there's room that we can cut the tongues out of it to assemble our window. One of the reasons why they do that, by the way, they actually cut a groove all the way down the side of this. There'd be a groove all the way down. They do a groove in the top and bottom as well, and that's the groove that they use to seat the glass into the window as when they put together the frame. If you're doing a double pane, that could be however thick your spacing is going to be between the windows. You space it with wood and it fits right into that groove. But anyway, let's figure out that length. Well, we need to look at this. We have one way we can go about this, and there are a couple of ways. The way I'm going to go about it is I'm going to find the size of this opening in here first. And then I'm going to add my tongues back onto that. So that opening is our 32 3/4, subtracting our two sides of 2 3/4. So 2 3/4, I could multiply by 2. I think it'll be easier just to add it to itself. 3/4 and 3/4 is 6/4. So that is 1 1/2. 1 2/4 is 1 1/2. So I keep my half, carry my 1. 1, 2, and 2 is 5. So I'm losing 5 1/2 inches to my two side rails. So I have to take my 32 3/4 minus 5 1/2. Now, before I even write in the 5 1/2, what's my common denominator going to be? It'll be 4, and 1/2 is just 2/4. So 3/4 minus 2/4 is 1/4. Got to borrow for the 2. This will be 2, and this will be 12. 12 minus 5 is 7. So 27 1/4 is my distance in between here. What do I have to add to that 27 1/4? 5/8 and another 5/8. So I'm going to do is my 5/8. I could multiply by 2. Probably the easiest here. Make that 2 over 1. Cross cancel the 2 and the 8 gives me 1 and 4. 5 times 1 is 5. 4 times 1 is 4. That's 5/4 or 1 1/4. Now the question is, what do I do with the 1 1/4? You might be tempted to subtract it, but remember, the 27 1/4 that we calculated goes from here to here. The tongues there that we're cutting have to extend out past that. So that 1 1/4 inches for the tongues has to be added to the 27 1/4. So 27 1/4 plus 1 1/4. 1/4 and 1/4 is 2/4 or just 1/2. 7 and 1 is 8. And the 2, 28 1/2. What do you think? Not terrible? Okay. Let's look at one similar to this that I'm going to have you guys try in your notes. We have a 48-inch tabletop. On each side of the table, we're going to come in 3 1/4 inches. And that is where the legs are going to mount, 3 1/4 inches from the edge. Each of our legs is going to be 2 3/8 inches. We are going to do a rail that fits in here, but we're going to do a mortise and tenon. I don't know if you guys are familiar with that term. What a mortise and tenon is, kind of like a tongue and groove. It's just going to be, there's going to be a piece of this wood right here that sticks out and fits into a slot in the legs on each side. So that tenon that sticks out is going to go into there 3/4 of an inch. What I want you to try to figure out for me in your notes, go from there to there. What's the total length of that blue piece have to be to not only be long enough to fit between the legs, but also be long enough to have that tenon on each end? So in your notes, see if you can figure that out quick. Anybody struggling to see where to begin on this, I'll give you a hint. Find the distance between the legs, then add the 2 3/4 inch tenons to it. You guys look like most of you are done there. There's a couple of you still working, but let's see how you did so far. So we have our 48 inches total. From that, we're going to have to subtract our 3 1/4 on each side. So I'm going to do this. I'm going to add my 3 1/4 to itself. 1/4 plus 1/4 is 2/4, or 1/2 again. 3 plus 3 is 6. So that's going to have to be subtracted. I also have my 2 3/8 inch legs. So I'm going to add those to each other. 2 3/8 plus 2 3/8. 3/8 plus 3/8 is 6/8, which is 3/4. 2 and 2 is 4. So I have to subtract 6 1/2 and the 4 3/4. So I'm going to add those together and then subtract them together. You'll notice I didn't write down the 1/2 after the 6 yet, because I'm going to write that in as 2/4. So I'm adding together yet. So 2 and 3 make 5/4. Which is 1 1/4. So I have 1/4, carry the 1. 1 and 6 make 7, plus 4 is 11. So I'm losing 11 1/4 inches on the two sides total. So I'm going to take my 48 inch and I'm going to subtract 11 1/4 inches. Now again, your calculator does this for you, but if we're not using a calculator, how do I take a 1/4 inch away from nothing here? Well, I have to have common denominator, so I'm just going to put in 0/4. Has a common denominator. Now I can borrow from my 8. This is a 7. My denominator tells me what I have to add to the numerator, so I'm going to have to add 4. That's now 4/4. 4 minus 1 is 3/4. 7 minus 1 is 6. 4 minus 1 is 3. 36 3/4. That is the distance between, from the inside of the leg to the other inside of the leg. But I have 2 3/4 inch tenons to add on to that length. But what is 3/4 plus 3/4? 1.5. Very good. Good to hear somebody that can rattle that one off. Like I said, as you get into construction more, the force you're going to be able to calculate very quickly. So 36 3/4 plus 1.5. Again, I'm going to change my 1/2 to 2/4. 3/4 and 2/4 make 5/4, which is 1 1/4 again. So I've got my 1/4, carry my 1. 1 and 6 is 7, plus 1 is 8. And 3, 38 1/4 inches. How many of you had 38 1/4? Perfect. Okay, we're going to do one more example, and then I'm going to give you guys some time to work on the quiz. This new example, though, might be a little tougher. We have a bookcase that has an overall height of 66 3/4 inches. It contains 4 shelves. The top is a shelf, by the way. So if you're looking at a bookcase, that top piece counts as one of the 4 shelves. Each shelf is 5/8 of an inch thick. The top of the bottom shelf is 4 1/4 inches from the ground, from the floor. What does that mean? Well, that means that bottom shelf is sitting down here. The top of it is 4 1/4 inches from the floor. The shelves are equally spaced. So what's my question? Find the size of the spacing between the shelves. I want to see if you guys can do this. I purposely did not draw you an illustration of this one. I want to see what you guys can come up with without a picture on this one. I'm going to give you guys about 3 or 4 minutes here to see what you can come up with. We'll talk about a minute, and then maybe give you a little bit more time to keep working on it. Okay, it looks like you guys might have an answer, so let's take a look. This is one that I would not try to do without drawing a picture. The overall height is 66 3/4 of an inch. So there's a simple start to our picture. 4 shelves. But I'm actually going to jump down to this piece of information before I do the 4 shelves. The top of the bottom shelf is 4 1/4 inches from the ground. So that means that is 4 1/4 inches. Before I do anything else, what does that mean then for this distance from here up to here? Well, it is 66 3/4 minus 4 1/4. I'll trust you guys to verify the math. That is 62 1/2 inches from here, the top of the bottom shelf. Notice that's the top of the bottom shelf. And the reason I specified the top, the thickness of that bottom shelf doesn't play into anything anymore. So that is my first shelf. That's shelf number 1. We did say that the top counts as a shelf. So that's shelf number 4 up there. So we got shelves 2 and 3 in the middle here. The thickness of the shelves is 5/8 of an inch. So we've got this one, and this one. 5/8 of an inch 3 times. Let's go ahead and deal with that. 5/8 times 3. Make it 3 over 1. 5 times 8. That's not dark enough. 5 times 8 is 5 times 3 is 15. 8 times 1 is 8. That is 1 7/8 inches. So the thickness of the shelves takes up 1 7/8 inches from our 62 1/2. So I'm going to have to subtract that out of my 62 1/2. Now I have to change my 1/2. Now I'm going to cheat here a little bit and just write over it to 4/8. When I go to subtract, 4/8 minus 7/8 can't be done. So I borrow, this becomes a 1. What do I have to add to my 4? The denominator is 8, so that becomes 12/8. So now we have 12 minus 7 is 5/8. 1 minus 1 is 0, and 6. So 60 5/8. What am I going to do with that 60 5/8? Well, I want to know how big each of these spaces are. There's only 3 spaces. How many of you, show of hands, did 4 spaces instead of 3? Okay, I figured a few of you would get caught with that. That's usually the common mistake on a problem like this. To get 4 shelves, you only need 3 spaces. So we have 60 5/8 divided by 3. So if you're using the calculator again, it's not a big deal, but let's do it by hand. 60 times 8 is 480, plus 5 is 485 over 8. Dividing by 3 over 1 is going to be times 1 over 3. 485 times 1 is 485. 8 times 3 is 24. So 485 divided by 24. This is one that a lot of people will make some mistakes on, because we've got 24 does not go into 4. 24 does go into 48 twice. 2 times 24 is 48. There's nothing left over. We bring down the 5. 24 does not go into 5, but we do have to remember to put a 0 up here. A lot of people forget that 0. So it is 20 5/24 of an inch. Now something we're going to address, maybe not on Friday, but probably Wednesday of next week, is obviously 20 5/24 is not a measurement on our tape measure. So how do we convert something like that into something on our tape measure so we can actually measure it out? We'll deal with that in a future class. Like I said, probably Wednesday of next week. Okay, does anybody have any questions on what we covered today? Well, the good news, I know I've been cutting it really short with the homework time, so you guys have had a lot of homework to take outside of class. There is no new homework today, but there is a new quiz there. Mr. Berghammer, do you have that ready for him? Okay, thank you. Like I said, I wanted to make sure I gave you guys at least 20 minutes for that today, since I've been cutting you short on work time and quiz time. So for the rest of the hour, if you want to work on that quiz, like I said, I'll get started grading those other quizzes this evening and tomorrow, and I'll have those back to you guys by Friday's class.